Great. Thank you, HL, for that very kind introduction. And I think you couldn't have introduced my topic any better when you said that the RIC is the most central element to the success of Open RAN. And what I am planning to speak in my session today is actually more about the RAN intelligent controller, the RICs. And I'm going to explain how the RIC holds the key to unlocking the full potential of Open RAN. So before I begin, I would like to thank the organizers for giving me an opportunity and inviting me to speak to this forum. I'm really looking forward to this. Okay, so I'm not sure how many of you saw this press release from Vodafone UK a few months back, where Vodafone announced that it has trialed a technology that increased the capacity of a 5G cell site by twofold using a technology, an entity called RAN Intelligent Controller. Right. So what is this RAN Intelligent Controller and how did it help Vodafone increase the capacity of a cell site? This was actually an increase in spectrum efficiency by twofold. And let me just emphasize, what this means is that the spectral efficiency was increased by 100%. Spectrum, as you know, is the most expensive asset resource of a telecom operator. Operators around the world spend billions of dollars to acquire and manage the spectrum, and several hundreds of millions of dollars more to get the most out of the spectrum. Maximize the spectral efficiency. Even a 3%, 5% increase in spectrum efficiency is considered a very big deal in this industry. And here is Vodafone announcing that it has trialed a technology that allowed it to increase the spectrum efficiency and cell capacity by 100%. So how did this happen and what is this RIC that made this happen is going to be the focus of the rest of my talk. So I've divided this session into two halves. In the first half, I'll explain what the RAN Intelligent Controller is all about. Many people that I talk to come across tend to equate Open RAN with Open Front Haul and Virtual RAN. And I'm actually going to explain why Open RAN is actually much more than Open Front Haul and Virtual RAN. And like I mentioned at the beginning, why the RIC is so central to the success of Open RAN and how it takes Open RAN beyond just Open Front Haul and Virtual RAN. In the second half, I'll talk about the product that my team at VMware is building, the VMware RAN Intelligent Controller. And I'll explain how it allows operators to modernize, optimize, and customize their radio access networks. And I'll dive a little deeper into this Vodafone UK press release that we just saw at the beginning. Okay. So let's start by understanding what the RAN Intelligent Controller is all about. So first, we need to understand the concept of open radio access networks. And let me explain how Open RAN is different than traditional RAN. When I think about traditional RAN, the mental picture, the mental model I have in mind is the radio access networking infrastructure packaged into a closed and proprietary box that comes from a single vendor. With the radio unit, the baseband unit, and the management unit all vertically integrated in this closed and proprietary box. And furthermore, even within the baseband unit, you have the data plane components of the baseband software that is very tightly integrated with the specialized hardware on which it runs, and also very tightly integrated with the control plane. The control plane is what contains the intelligence in the network. It contains the intelligence that drives the data plane. So in traditional RAN, the data plane, control plane are very tightly integrated with each other and with the hardware on which it runs, and the entire stack from the management plane to management unit to baseband unit to radio unit is all vertically integrated. And there is very little programmability available out of the box. So when once a telecom operator purchases this box, there is very little that it can change about the intelligence that has already been hard-coded, embedded within that box, right? So it makes it very difficult for operators to adjust the intelligence in the network specific to its own deployment and its own requirements. And this is the traditional RAN architecture that has been employed for over 40 years that commercial radio access networks have been in existence. But now this architecture is undergoing a massive transformation. I would say a once in a lifetime transformation, where this traditional RAN architecture is being fundamentally re-architected. And there are two big transformations that are happening. The first big transformation is the introduction of network function virtualization to radio access network. Network function virtualization is about virtualizing your software so that they run agnostic to the underlying hardware. And then you take it one step beyond. Once you virtualize, you also then move to the cloud. So you not just virtualize the software, but then you move it to the cloud, make it cloud native. So the first step towards virtualization is to disaggregate the radio unit, because the radio unit is a very special piece, very special hardware-defined piece, very hard to virtualize. So the first step to virtualizing and making the RAN cloud native is to disaggregate the radio unit. That's where the open front haul came in. The open front haul was a standard interface between the radio unit and the baseband unit that allowed the radio units to come from potentially different vendors than the vendors providing the rest of the baseband unit. And once you have disaggregated the radio unit, the rest of the baseband unit can be now virtualized and can be made cloud native and can be moved to the cloud, can be made to run on a cloud platform on industry standard hardware, no longer special hardware, right? So the virtual RAN, this is known as virtual RAN when you bring NFV to radio access networks, is the beginning of a multi-vendor RAN. Now, instead of a single vendor, operators can now rely on multiple vendors. The radio unit could come from a different vendor. The hardware, the servers for the baseband unit could come from a different vendor. The cloud platform could come from a different vendor, and the rest of the RAN software could come from a different vendor. But virtual RAN is still not programmable. Virtual RAN is still single vendor. If you look at this software, the baseband unit and management unit, the management unit is not interoperable with the baseband unit. You cannot take a management unit from one vendor and make it work with a baseband unit from another vendor. You can't take a control plane from one vendor and make it work with the data plane of another vendor. So the RAN software, even though it has been virtualized and made cloud native, is still single vendor in nature. And this is where the next big transformation is changing this architecture. The second big transformation that is happening in the traditional RAN architecture is the introduction of software-defined networking. Software-defined networking is about decoupling the intelligence of the network from the data plane of the network, or in more technical terms, decoupling the control and management planes of the network from the data plane. So in a software-defined radio access networks, the data plane, the RAN data plane, exposes programmable interfaces towards the control plane and towards the management plane. And furthermore, the control plane and management plane themselves are architected as a platform that provides APIs for third parties to build various features and functions as applications. So in a software-defined RAN, you have the notion of a control plane platform that integrates with the RAN data plane on one side and provides APIs for third parties on the other side. And third parties can now come and build various control plane functions as apps that run on this control plane platform. And similarly, there is a management plane platform that integrates with the RAN data plane on one side and then provides APIs for developers. So third parties can come and build various management plane functions and features as applications that run on this management plane platform. So software-defined networking is what makes radio access networks truly multi-vendor, because now each of these control plane applications and management plane applications could come from a potentially different vendor. So from one vendor in traditional RAN to maybe 3, 4, 5 vendors in virtual RAN, you now go to tens or even up to 100 vendors in a truly open RAN, which has software-defined networking. And software-defined RANs are programmable because now you have third-party applications that can program the RAN, that can change or insert new intelligence, new capabilities into the radio access network. So where does the RIC come in here? The RIC is basically the ORAN Alliance defined kind of architectural element for this control plane platform and the management plane platform. So what you are looking at on this slide is the reference architecture published by the ORAN Alliance, which is an industry consortium, operator-led trying to standardize the architecture and interfaces for Open RAN. What ORAN Alliance has done with this reference architecture is it has taken the traditional closed and proprietary RAN and disaggregated it into these different modular components and defined the interfaces, the open interfaces between any two modular components. So starting from the bottom right here, there is the open front hall interface, which allows the radio unit to be disaggregated from the rest of the business, the baseband unit. ORAN Alliance has defined this O cloud, which is that cloudification and virtualization layer we talked about, which abstracts the underlying hardware and allows the baseband software, the CUCP, CUUP, and DU to run in a virtual or containerized form factor. And then ORAN Alliance has defined what is known as a near real-time RAN intelligent controller. This is the control plane platform that we were looking at in the conceptual picture on the previous slide. What the near real-time controller does is it integrates with the RAN baseband software via this new interface called the E2 interface. E2 interface is the new programmable interface that the baseband elements, the CUCP, CUUP, and DU expose towards the RIC. And then the RIC in turn exposes APIs for these third-party applications called XApps. XApps is the ORAN Alliance term for the apps that run on a near real-time RIC platform. These are the RAN control plane applications. Similarly, as part of the management unit, which ORAN Alliance calls the service management and orchestration, or SMO, there is a non-real-time RIC. And this non-real-time RIC is the RAN management plane platform that we looked at in the conceptual picture on the previous slide. And what the non-real-time RIC does is it interfaces with this O1 interface with respect to the RAN baseband software, and also with this A1 interface, which is another new interface with respect to the near real-time RIC. And it is responsible for the management functions, the slower timescale functions, greater than 1 second timescale functions, the management of the RAN baseband software, as well as of the control plane, the near real-time RIC, right? So why is this important? Why is the near real-time RIC important for an operator? Why is the non-real-time RIC important for the operator? There are 4 key reasons. The first big reason is that it improves flexibility. It improves vendor choice, right? So like we were just discussing, now instead of relying on the single RAN baseband vendor to provide all the intelligence that is needed for operating and optimizing the radio access network, now an operator can tap into a much larger ecosystem to build these various XApps and RApps, to build these various intelligent functions for its radio access networks. Flexibility is one key benefit. The second big advantage is customizability. So when an operator today procures RAN software from a legacy vendor, the legacy vendor sells them a one-size-fits-all solution. It's the same solution that an operator in India would get and an operator in Europe would get. But now with the RAN intelligent controller, it becomes way more easy to customize the network, for the operator to customize its network based, for its own specific deployment scenarios, for its own specific business needs or business preferences, because it can now program the intelligence that was earlier embedded, hard-coded within the infrastructure via this RAN intelligent controller. The next big advantage is agility. So now it becomes very easy to introduce these new capabilities or enhanced capabilities in the radio access network in a very agile manner via the the RAN intelligent controller. Earlier, if you had to introduce a new piece of intelligence, you basically had to rely on your RAN vendor to provide a new upgrade of the software, right? But now new capabilities can be introduced in the network in a very agile manner without touching the underlying RAN baseband software. So you can introduce a new XApp or a new RApp, which gives you a new capability without having to change or upgrade your CUCP or CUUP or DU. So agility improves several folds. And the fourth, last but not the least advantage is performance. By opening up the intelligence to a much larger ecosystem, by cloudifying this intelligence, extracting it out of the CU and DU and moving it to a central location where the RIC runs, and by using advances in AI and ML, and by using advanced compute capabilities and GPUs and enhanced libraries of x86, you can now perform a lot of the functions in a much more optimal manner. So you get a significant increase in performance, increase in your spectrum efficiency, like you saw in the Vodafone trial, or improvement in subscriber KPI, subscriber experience. So flexibility, customizability, agility, performance, all of them improve significantly by the introduction of the RIC. And that is why the RIC is a very central component in the Open RAN architecture and is key to the success of Open RAN. So with that understanding, I'll now move to the specific product that we are building at VMware, the VMware RAN Intelligent Controller, which is a production-ready implementation of the near real-time RAN Intelligent Controller and the non-real-time RAN Intelligent Controller defined by O-RAN Alliance. So VMware is building two products. The centralized RIC is the VMware product name for the non-real-time RIC, and the distributed RIC is the VMware product name for the near real-time RIC. And VMware is building the centralized RIC and distributed RIC to support its any app, any RAN, any cloud vision. So let me explain this vision, this product vision and strategy of VMware with respect to its RIC. The any app vision means that we are building the centralized and distributed RICs to support any use case that operators want to introduce in their networks by any vendor that operators want to introduce in their networks. So be it an automation use case like a PCI conflict resolution or a mobility load balancing, use cases that are focused on lowering the time to resolution of common network or subscriber problems or lowering the OpEx, or be it optimization applications like energy savings, like traffic steering, like MU-MIMO optimization. So these are applications that are focused at improving subscriber experience and spectrum efficiency, or be it monetization application. This is a new category of applications that are made possible by the open and programmable interfaces that RANs expose now. It is now possible to build entirely new capabilities, new services that can become new revenue streams for operators. So capabilities like geolocation, which is the ability to infer the 3D location of a device based on its channel measurements. So in deployments where GPS doesn't work well, like indoor locations and basements, or even in dense urban locations where GPS is not reliable, and if there are location-based services that need to know the location of the devices, it is now possible to offer location via the radio access network itself. You could have a geolocation XApp that is inferring the location of the devices of interest based on their wireless channel measurements. And by introducing a geolocation XApp, the operator can now expose a location API to any external location-based service that would be interested in paying for this service to get access to reliable location. So this is an example of a new capability that the operator can introduce in its network via the RIC. RAN slicing SLA assurance is another capability, the ability to create virtual slices and sell it to enterprises or to premium subscribers who are willing to pay to get a dedicated slice of the network. It's another example of an application that can help operators create a new revenue stream. So any use case and all use cases that operators want to introduce in the network, we are building the RIC platforms to be able to support that. And by any vendor, like I said, the goal is to open up RAN innovation to the larger industry ecosystem. So what we are also offering is an SDK, a software developer kit that any third party can download and use to get jump-started with the app development process. The SDK makes it really easy to develop R apps and X apps for a radio access network, right? So this could be the same RAN vendor who may be building some R apps and X apps. This could be a third party, like a startup, another company, could be research organizations. In fact, we are working with an operator in India who is partnering with academic institutions in India, and the grad students and professors are doing research on how to build some of these innovative R apps and X apps. The operators themselves have R&D teams, data science teams who can build some of these R apps and X apps. So operators themselves can build these new capabilities very easily using the software development kit for their own networks. And VMware also is building a few R apps and X apps. So that is the any app strategy, any use case, any vendor. The any RAN strategy means that the distributed and centralized RICs should be able to support any RAN. It could be open RAN, which supports the O-RAN alliance-defined interfaces like E2 and O1, or it could be legacy RAN. The centralized RIC, the non-real-time RIC specifically, can be introduced even in legacy RAN, where the O-RAN interfaces don't exist. But in legacy RAN, there are vendor-specific interfaces and SON kind of interfaces that can be used to introduce a lot of these RAPs. So we are building our RICs in a way that can be introduced in any RAN, and these are truly RAN vendor agnostic and multi-vendor in nature. So it gives maximum flexibility to operators to choose any RAN vendor for the network that works best for them, or any mix of RAN vendors, and they can be assured that the RIC platform will work across the mix of RAN vendors. This can support 4G or 5G. So we are building a vendor neutral platform. And then the any cloud part of the strategy means that the RIC platform and the XApps and RApps can be run on any cloud platform that the operator has chosen for its network. So different operators have different strategies when it comes to the cloud. So we are building the RIC platform and the XApps and RApps in a truly cloud native manner, Kubernetes native manner. So you could run them on a Kubernetes cluster of a hyperscaler like an AWS EKS platform. You could run it on VMware's distribution of Kubernetes, which is TKG, Tanzu Kubernetes Grid. Could even run it on Kubernetes on bare metal. So depending on what the cloud strategy is for the operator, could run the RIC on any cloud. So that's the any app, any RAN, any cloud vision that we are building towards. So let me now come to the case study, and I'll conclude with this case study. So in this particular trial that I mentioned at the beginning, what Vodafone actually trialed was the VMware distributed RIC, the near real-time RIC. And we had a partner, a startup in Silicon Valley called Cohere, which built an XApp for MU-MIMO optimization, right? And what this XApp does is basically MU-MIMO, as some of you may know, stands for multi-user MIMO. It's a technology that allows you to transmit to multiple users simultaneously over the same time and frequency resource. Typically, since the wireless medium is a broadcast medium, if you want to transmit to multiple users, you have to divide them either in time or frequency. You have to multiplex them in time or frequency. But with multi-user MIMO, you can actually transmit to multiple users on the same time and same frequency slot. So it's a technology to boost the spectral efficiency and therefore the cell capacity. And this MU-MIMO is as a data plane feature has been standardized for a long time by 3GPP, but it's very hard to make it work in practice because it requires a very high degree of intelligence. Without a high degree of intelligence, using MU-MIMO actually turns out to be worse than not using MU-MIMO. And specifically, the intelligence is required in choosing which users you pair together for transmitting to simultaneously. This is called the user pairing problem. And once you have paired those users, how do you pre-code the transmissions so that each user can decode its transmissions without seeing interference from the other users? This is the user pre-coding problem. So you need to be very smart about user pairing and user pre-coding for MU-MIMO to actually work well in practice. And it's such a difficult problem that even the tier 1 RAN vendors today rarely use MU-MIMO in practice. So even though the technology has been standardized by 3GPP, it's rarely used in practice. And this is where comes Cohere. Cohere is a startup that has done a lot of research and innovation in how to make MU-MIMO work in practice. And what Vodafone did here as part of this trial is introduce the Cohere MU-MIMO innovation as an XApp via the RIC platform into its network, right? So instead, without the RIC platform, it would have been very hard for a startup like Cohere to commercialize such a technology and bring it to a live network, because Cohere would have to work with each of the major RAN vendors to integrate this technology natively with their RAN software. But now it is possible for the Cohere innovation, Cohere technology to be introduced via the RIC. And that is exactly what Vodafone did. And the result was a 2-fold increase in spectrum efficiency and cell capacity. So this is just one small success story of what the RIC can enable. This is just the beginning. Like I said, there are tens of applications that different vendors, different companies around the world are working on that we are looking to onboard by the RIC platform. And this is why I said at the beginning, the RIC is going to be a very key piece in the success of Open RAN. So that's all I had to say. Back to you, Echar.
Thank you, Rakesh. And